In this section, we're going to be actually calculating mathematically from the components of a vector to figure out what the vector would be. We did it graphically in the last section, and so now we're going to start to analyze it mathematically. The two formulas that he gives you in the book is that the magnitude of the vector is, you're just going to take the Pythagorean theorem and take the x component, the y component, square them, and then take the square root of that to find the magnitude of the vector. And we also talked about in the first video for this chapter that if you want to find the angle that it makes with the x-axis, that you have to take the inverse tangent of the y component over the x component. Now, you have to be careful because the answer that your calculator gives you is not always going to be the way that physicists define that angle. We had said that we wanted to find the angle from the positive x-axis in a counterclockwise direction. Now, the problem is that your calculator is going to define that angle according to whichever x-axis it happens to be the closest to, and not necessarily from here going this direction. So you have to watch as to which coordinate or what the coordinates are that your components have, figure out what quadrant that answer is in, and then you're going to have to make some adjustments to figure out what the angle is in the terms that we want to use it. Now, if it turns out that your vector is up in this quadrant, which if you remember from algebra, this is the first quadrant, then the angle is perfectly fine the way that your calculator gives it to you. So if the vector is in this quadrant, you don't have to do anything to it. If the vector is over here, though, in the second quadrant, your calculator is going to give you the angle from the negative x-axis and not the positive x-axis. So if you see that the vector actually is up in this direction, then you're going to have to add 180 degrees to the answer so that you get that answer within the range that we want it to be in according to the positive x-axis. If it comes down so that it's in the third quadrant, you're going to have to do the same thing. Oh, dropped my pen there. So you're going to have to add 180 degrees here. And if it's down in the fourth quadrant, your calculator is going to measure it from the x-axis, but it's going to go this direction when your calculator does it. So you have to add 360 degrees if it's down here. Now that may seem a little complicated. You're going, oh, how am I going to know which quadrant it's in? Well, I'll show you how to do that. So we're going to work through example 3.3, the first half of that, just so that you can see me work it out and understand how to make that happen. So the problem that they give you in example 3.3 says that the x component of vector C is a negative 1.2 meters, and the y component of negative C, or vector C, is 3.4 meters. Okay? So if you look at this, which quadrant is that in? Well, the x component is negative, so you're going to go this direction. The y component is positive, so you're going to go this direction. So that means that you're up in quadrant 2, and so whatever angle you calculate, you're going to have to add 180 degrees to it. So as you can see, this isn't something that is difficult. You just have to analyze from the x and y components which quadrant your vector is actually going to lie in. All right, so let's figure out what the magnitude is going to be. The magnitude is pretty easy. So vector C, the resultant is going to be the square root of negative 1.2 meters squared plus 3.4 meters squared. And so when you do that, you should end up with 3.6 meters. Again, significant figures would tell me that this is in the 10th place, this is in the 10th place, so my answer is going to be to the 10th place as well. Okay, so 3.6 meters. One other way to check and make sure you haven't made a goofy mistake is if you're using the Pythagorean theorem to find the hypotenuse, obviously this number should be larger than either one of those two. So if you type something and you get an answer that's not bigger than the absolute value of either one of those, then you've goofed up someplace. You need to go back and try it again. Okay, so now let's check the tangent, or I check what the angle is going to be. So theta is going to be the inverse tangent of the y component, which is 3.4 meters, over the x component, which is a negative 1.2 meters. Make sure you put that negative number in there. Don't leave it off, because that will affect your final answer. I shouldn't have an equal sign in there. Sorry about that. So the inverse tangent of 3.4 divided by negative 1.2. So again, when you type this into your calculator, 3.4 divided by negative 1.2, hit the equal sign, and then calculate the inverse tangent from there. It should give you an answer of a negative 71 degrees. Okay, again, because my x component is negative, my y component is positive, it puts me up in this quadrant. So to get the appropriate answer, I have to add 180 degrees to this. This is going to be, this one had two significant figures because both of these had two significant figures in it. 180 degrees is exact, so I'm not going to use this to determine significant figures to my final answer. So my final answer will be in the units or the ones place. And so you should come up with a final answer of 109 degrees, which from here is still going to land us over in this quadrant. Okay? If you have trouble figuring this out, please make sure you ask me for help, because the next video we're going to flip this around and do just the opposite.